Good morning and welcome to the first video in a series of videos where we'll be exploring the world of organic compounds. As I've indicated before, this is a good series to watch if you are interested in taking Chemistry 30, as it actually takes away some of the pressure when you're taking Chemistry 30, because we're going to be doing it now. When we take Chemistry 30, there's often not a whole lot of time to spend lingering in basting in all the goodness. The pace is quite accelerated. So it's nice to do some of it in grade 11 and save us the hassle in grade 12. So I usually pick what I consider the easiest stuff from Chemistry 30, and I do it at the end of grade 11 in Chemistry 20. And that is organic compounds. It's a pretty interesting subject because this is kind of like the chemistry of life. It's something like, I think it's high 90s, like 95 to 97% of the chemicals that we know of on Earth are organic chemicals. And you might go to the store and you'll see the label organic and you think, oh, that's good. I should buy that. And they tend to be a little bit more expensive. Maybe they use more natural ingredients, less synthetically derived ingredients. And for the person who has studied any organic chemistry, you kind of have a different definition of organic. In the marketplace, organic means natural, better, upper class, upper echelon, expensive, maybe doesn't taste as good, but you know it's healthy. But to a chemist, organic really just means it's carbon-based chemistry. And I've drawn a few chemicals out for you, 3 of them actually. And these are some organic compounds. They're all carbon-based compounds. And you can see they have branches on them. They've got some hydrogens kind of lingering around. And they kind of form these unique structures. Well, organic compounds are compounds that are largely based on the atom of carbon. I'm not going to get too into the definition of what is an organic compound and what isn't an organic compound, but for your purposes, I'd be happy if you understood organic compounds to be compounds that have at least carbon-carbon bonds or carbon-hydrogen bonds. We'll see a few other organic compounds where they can have carbon bonded to halogens, but largely organic compound is carbon bonded to another carbon atom or at least to another hydrogen atom. So I've drawn a few for you already. And these are very simple ones, just carbons and hydrogens. CH4 over here is methane. Methane is the primary component in natural gas. It's one of the smaller organic compounds. Right here, this second one in the middle, this is called isooctane. There's another name for it, which we're going to go over in a few more lessons, but this is the component in gasoline where you see the octane rating. The octane rating is kind of telling you about how much of this chemical there is in the fuel. This guy over here, I just drew randomly. It looks kind of funky, and I like what it looks like. So those are 3 organic compounds. There's a whole bunch of other compounds too. We can add oxygens and we can add nitrogens and sulfurs and phosphorus into our compounds. And I'll just draw a few out for you right now. This one here, this is called acetic acid. This is acetic acid, which is the primary component of vinegar. It's an organic compound. And notice it has oxygen in it. Here's another one. It's going to look kind of weird. There's a whole There's lots of different ways that we can draw these things. This one here, this is ethanol. It has an oxygen bonded to a carbon, and then there's a hydrogen on the other side of the oxygen. This is ethanol. This is the primary alcohol found in beverages. It's also used in antibacterial soaps and cleansers and that kind of stuff. So this is ethanol here. It's used a lot in organic chemistry as a primary ingredient to build bigger and better molecules. Okay, so those are two examples that you can have with oxygen in them, and we're going to see lots and lots of other ones too. You probably already have seen some sketches of organic compounds like this before. If you've studied biology, you can probably think of a few right now off the top of your head. Monosaccharides like glucose and fructose are organic compounds because they are built off of carbon. Amino acids are also organic compounds. Okay. Amino acids are also organic compounds. Amino acids have three carbons in them at least. Sorry, not three carbons, two carbons. That's a nitrogen, carbon, and then you have a carbon bonded to oxygens at the end. And I should fill this out too. That has hydrogens in them too. So this is an amino acid that you've probably seen in biology. They are the building blocks of proteins. They are also organic compounds. So when we're talking about organic compounds, we are talking about carbon-based compounds. So the question then is, why carbon? Like, why don't we see this diversity of chemicals coming out of, nitrogen or phosphorus or silicon or, sodium for that matter? Well, it's largely because carbon, being in group 14, has 4 valence electrons, which means that carbon is unlikely to form ions because it would take a lot of energy for carbon to lose 4 of its 4 valence electrons, and it would take lots of energy for it to gain another 4 electrons. So it's unlikely to form ions. So what it does instead is it forms covalent bonds. And the covalent bonds that it forms are very strong. It forms strong covalent bonds. And these bonds can be single bonds to other carbons, they can be double bonds to other carbons, or they can be triple bonds to other carbons. It also forms a very strong covalent bond to hydrogen. And when you form a strong bond, this means that these bonds are a little bit more stable than other bonds. And if the bonds that make up your molecule are very stable, that means your molecule can last. It can perpetuate. It can exist long enough that it can, stay in the ground like fossil fuels, or it can persist just long enough that maybe one of its special groups might be able to take part in some interesting chemistry. So carbon forms these very strong covalent bonds, and it also does something that's kind of unique to carbon. It catenates easily. And catenate is just a fancy word for chain. It chains easily. And you can see a few examples of it where it's chaining. Carbon will form these strong covalent bonds with other carbon atoms. And because of its 4 single valence electrons, it has a bonding capacity of 4. This means it can form a variety of bonds to other carbon atoms. It could form, 4 single bonds. One carbon atom can make 4 single bonds to other carbon atoms, like this carbon over here, or it could bond to 2 other carbons and 2 hydrogens. Or if you're like these carbons here, you could form a double bond with each other and then 2 single bonds to other carbon atoms. So because carbon has its 4 valence electrons, it's going to form very strong covalent bonds, and it's going to chain very easily to make a variety of structures. All right, so when we're talking about organic compounds, we're talking about carbon-based compounds. We see lots of hydrogen in there too. So we're looking at compounds that at least have a carbon-carbon bond or at least a carbon-hydrogen bond. There are some exceptions to this. So maybe I'll briefly go over those exceptions here. I'm not going to spend too much time going over the exceptions of carbon compounds that aren't organic, but the exceptions would be anything that has a carbonate ion in it, or a cyanide ion, or a carbide ion. Those are not considered organic. So we call them inorganic. Some of this is a little bit arbitrary and has more to do with historically how people have defined organic compounds. I'm not going to spend really any more time after this kind of explaining why these aren't, but I'll save that for next year. All right. Next video, we're going to talk about kind of how we can organize and classify different types of organic compounds, and then we'll dive into our first class. All right, see you then.